Mrs. Gallagher here. I want to give you some more information about the index lab stations, and hopefully this will help you understand some of this, make it a little clearer for you. The first thing is we want to talk about the geological time scale. We haven't talked much about this yet. We'll be getting more into it after we get back from our break, but think of it like a timeline that you would have in math, where the numbers that are on the left go further back, way back in history. The numbers on the right are more current. So if you're looking at this timeline right here, we have 600 MYA, or million years ago, 550 MYA, million years ago, etc. And then as you go to the right, it gets closer and closer to us in age, even though it's still a long time. Like this one is 50 million years ago. It's closer than the one on the extreme left, but it is still a long time ago. Okay, so that's what the timeline looks like if it were horizontal. Most of the time when you see geological time scales, they are not horizontal, they're vertical, but more on that later. Okay, so the fossils are remains of once living organisms that have been preserved in sedimentary rock. Remember, we talked about the rock cycle last week. They can only be formed in sedimentary rock. However, going through the rock cycle, the sedimentary rock can be changed into igneous or into metamorphic rock. But fossils only form in sedimentary rock. You have index fossils, and these are fossils that are used for determining the relative age of the layer in which it was found in. So when I'm talking about relative age, it's also called relative dating. It is the science of determining the relative order of past events without determining their estimated age. For example, if I ask you how old you are, you're going to give me a certain number of years, 12, 13, 14 years old. That is not relative dating or relative aging. That is an exact date. When we have fossils, we just want the relative age. We want to know about when they were because we cannot determine their exact date. Now, remember our POGIL activity where we looked at Grandma's memory box of Janae's drawings, and she had things in a relative order. So the first drawings when Janelle was age 2 are on the bottom, and then as Janelle has more drawings, Grandma puts them on top of the box, and so the most current are at the top of the box. So again, this is just relative. Even though we know how old Janelle is, we don't know the exact date of when those drawings were. So that's exactly what we're doing here. We're figuring out what's oldest and what's youngest. We're figuring the approximate date of the fossils by comparing them to index fossils. Since we know the relative date of the index fossil, because that was given to you on the table, we can come up with a pretty good idea of the age of the other fossils. Now, this is very important. In order for a fossil to be characterized as an index fossil, there are two things it has to do. First of all, it has to be widely distributed, and second, it is in a limited time span. So remember that. That is very important. Index fossils are widely distributed and in a limited time span. So when we say widely distributed, we mean that it's found in many parts of the world, not just in the United States or not just in a certain country, but all over the world in many places. It has to have a limited time span. This means that the organism was alive for only a short time, and when it died, there were not other generations of it reproduced. So it's not like humans where we have generation after generation after generation. These organisms became extinct, and they only lived a short time. So those are two criteria for something to be considered an index fossil. So you have an outcrop. An outcrop is any geological formation exposed on the surface of the earth. And the horizontal layers in there that you can see in this picture right here are called strata. Strata means layers. So think about last year you learned about stratus clouds. They are the ones that are in layers. And so here we have a picture. This is the Grand Canyon, and you can see the different layers that they have in there. They're different colors, and they were formed at different times. The next thing is you have erosion. So erosion is the geological process in which earthen materials are worn away and transported by natural forces such as wind and water. We talked about this with our rock cycle last week. So right here we have an image where you can see some of the beautiful layers of the rock, but some of it has been worn away. So for whatever reason, it could be water, it could be wind, it could have been an earthquake, and different things. Part of that layer is not there anymore, and so that is erosion. So this affects the infects the layers of the earth where the fossils are found. Now, if you remember right here, we went over this one, and we said that the index fossil Q, which is an ammonite, the ammonite is missing from location B. We see the ammonite in location C, and in location C we see layer P, and we can see that in layer B, and then we see the fossils in layer R, and we can see those in B, but something happened in location B where that rock layer was eroded, and so it's no longer there. And so scientists figured this out by comparing their index fossils that they have found from all over the world and giving them an approximate date of when the organism was alive. And again, it's a really wide range. We're not talking 10 years or 20 years. We're talking millions of years. If you know the time frame that the fossil lived in, then you know the time frame that the layer of rock was formed. So if you know the time frame the fossil was formed, then or was in existence, then you know the time that the rock layer was formed. Also, like on location D, our outcrop on location D, there are not any index fossils there. So while we see that some of them repeat, like for example, the clamshell that you find in layers K, L, M, and N, it's too wide of a time span for those to be considered index fossils. So because those have lived for many, many different years. All right, hopefully this will help you some with your finishing your lab station and help you with your CER.